Hey everybody, this is Polar Unit Video 8, and we're going to be working with multiplying and dividing some complex numbers that are written in polar form. So let's go ahead and get started. Have your note sheet ready. All right, so what I'm going to show you first is how this works, and then you're going to be rewarded with a shortcut that you can use. But it's important that you know where this stuff comes from. If I were to ask a little more detailed questions, say on a test, you'd be able to answer a justification of why things work. It's nice to know shorthands, but it's important to know where these shorthand tricks, if you will, come from. So starting here, we are going to multiply these two polar points together, and then see these these rectangular numbers together, and then we're going to convert them. So here's how it goes. I'm going to start by just distributing this and multiplying it out. I'm going to get negative 2 root 3 plus 2i. Here when I multiply that, I'm going to have a negative 2 times the 3 because I'm squaring that radical, and then times the I, so negative 6i. And then the last one is going to be a 2i squared root 3, which we know the I squared makes that negative, so negative 2 root 3. So ultimately this becomes negative 4 root 3 minus 4i. So now I want us to convert this to polar form. So I'm going to find my r value and my theta value. That's negative 4 root 3 squared plus negative 4 squared. This gives me 4 squared is 16 times 3 plus the other 16 here gives me the square root of 64, or 8. Next, I'm going to find the tan inverse of my y value, which is negative 4, over the x value, which is negative 4 root 3. This is going to produce a 30-degree angle if I type that correctly in my calculator. But I know because they're both negative, my x and y values, that this is in the third quadrant. So my angle is actually 210 degrees. I'm going to write this in the shorthand cis form. That's 8 cis 210 degrees. Let's go ahead and try this a different way. Let's convert them first into polar form. Individually, I'm going to convert these numbers. So I'm going to find an r and a theta for each of them. Here, r equals the square root of 1 squared plus the square root of 3 squared. That will give me the square root of 4, or 2. When I do my tan inverse of root 3 over 1, I'm not using the I, I'm only using the coefficient, in this case the square root of 3. This gives me a 60-degree angle. Since both of our x and y values are positive, I'm going to keep the 60-degree angle because it's in the first quadrant. This gives me 2 cis 60 degrees. Let's try the other one. R is going to equal the square root of negative 2 radical 3 squared plus 2 squared. This is going to equal 2 times 2 is 4 times 3 is 12 plus the other 4 gives me the square root of 16, or 4. I'm going to do the tan inverse of 2 over negative 2 root 3. My calculator is going to produce the answer of negative 60 degrees. Negative 30 degrees. Said that fast and then went back and changed my mind. But I know it's not in the fourth quadrant, so I'm going to have to place this in the second quadrant at 150 degrees. So this is 4 cis 150 degrees. I'm going to change the next screen, and you're going to see these two numbers at the top of our page. Our goal is to come up with 8 cis 210 degrees. Here they are. They're written in longhand. I'm going to shorten them again for you. 2 cis 60 degrees and 4 cis 150 degrees. So if my goal is to multiply these two things together and come up with 8 cis 210 degrees, that's what I got when I did the long way, let's find a shortcut. How can I make these two, using multiplication, turn into this? Well, the r's seem pretty obvious. 2 times 4 makes 8. But what about the 60 and the 150? How am I going to get them to equal 210? Well, if you're thinking addition, you're absolutely right. I'm going to skip this next step here, and we're going to go on to the next screen of my show here, or my video. So our rule is going to be that if I have two numbers in polar form, r cis theta, times another r cis theta. Now my subscripts here are just to represent that they're two different values. I'm going to, in shorthand, add my radial values together. Cis, did I say add? I meant multiply those guys. And we're going to add the theta values together. So we are multiplying the radius, multiplying your r values, and we're going to add the theta values. And this is how we multiply complex numbers that are written in polar form. If we had to multiply complex numbers in rectangular form, we just use distribution. Let's keep going. So I want us to try two examples together, and I'm going to leave 3 unanswered. All right, so we're going to multiply the r values, and we're going to add the angle values. So I'm going to write this in the shorthand, and I get 180 degrees. This is our answer. Next, 4 and 6 get multiplied, and then I've got 60 and 330, which I add together to get 390. Now we're going to keep our values between 0 and 360, which means another place for this point is 24 cis 30 degrees, and that's the best answer we're going to give. Please try example 3 and then go ahead and continue the video. All right, division. I'm going to show you the long way so that you know how it's done and you can justify your answers. So if I'm just given these two rectangular points, something we've been practicing plotting and all that stuff, then I'm going to have to use the conjugate. I'm going to go a little bit fast here because I'm really just multiplying these out. So if you need to pause and take notes, please do so. So the conjugate is negative 2 root 3 minus 2i. Negative 2 root 3 minus 2i, and I have to FOIL all of that out. Ooh, I said FOIL. And I'm going to have 1 times 2 root 3 is negative 2 root 3. 1 times negative 2i. I root 3 times negative 2 root 3 gives me negative 6i. And then I'm going to have I root 3 times negative 2i. So I root 3 times negative 2i, I'm going to get an I squared. It's going to cancel with that negative, so it becomes plus 2 root 3. This numerator right here that we have simplifies down to just negative 8i. Let's do the denominator. Because I chose the conjugate, I do not have to worry about my middle terms. They're going to cancel because they're opposites. That's the reason we use the conjugate. So I really have to worry about multiplying my firsts and my lasts together. So my firsts here are going to give me a positive 4 times 3, or 12. And then I'm going to have a 2i times negative 2i, or negative 4i squared, which we know to be plus 4. That gives me a denominator of 16. So to simplify this, I'm going to get negative 1/2 I. So what is the rectangular form of that number? It's 0 minus 1/2 I. My x value is 0, my y value is negative 1/2. Let's convert that into polar form. So my r value comes from the square root of 0 squared plus 1/2 squared, which turns out to be just 1/2, or negative 1/2. Turns out to be just a 1/2. That's my r value. My theta value will come from my tan inverse of, tan inverse of negative 1/2 over 0. Well, I can't really enter that in the calculator. It's not going to work out for me. So what I should do then is think about it graphically. There's no real value. There's only an imaginary value, which puts this at 270 degrees. Therefore, this in cis form is 1/2 for my radius, cis 270. Okay, so that's our goal for our division. Now, I'm not going to need to convert these because they're actually the same points that we were using in the first, for the multiplication example. So this is 2 cis 60, and this one is 4 cis 150. Okay? All right, so my rule for division, I'm going to show you what happens. It says that we have 2 cis 60 and 4 cis 150. And my goal is to come up with, what did I say? I'm sorry, 1/2 cis 270 degrees. Let's think about how we can do this. Well, the 2 and the 4, that seems to make the 1/2. So I'm dividing those. All right. So we're going to divide the R values. Sounds good. But what am I going to do with these two? If I add them, I get 210. That doesn't work. And I don't want to divide them. So what if we subtract them? Well, if I subtract 60 minus 150, I get negative 90, but I really want 270. Well, think carefully. Negative 90 degrees is exactly the same place as 270 degrees. So I really have found the answer by subtracting the theta values. Okay, let's try a couple. All right, so let's try 4 and 5 together, and I'll leave 6 for you to try on your own. Remember, we're going to divide or just reduce the fraction, leaving me 2 cis, and then I'm going to subtract the numbers, which will give me a negative 210 degrees. I want to keep my angles between 0 and 360 degrees, which means I have to add 360 to rotate back to a coterminal angle, which if I add 360 degrees, my answer is 150. This is your answer. Okay, for number 5, you have a couple options. We can either go ahead and rationalize this and then convert it to polar form, which is completely fine, or you can convert each and then use our shorthand here of simplifying. I'm going to suggest that we actually go ahead and rationalize it, 2 plus 2i and 2 plus 2i, and then we can convert afterwards. So this leaves me in the numerator 6i, and then I'm going to have 6i squared, which is just negative 6. Okay, and then for the denominator, when I multiply those, remember your insides will cancel. So that means I need my 2 times 2 is 4, and the negative 2i times the positive 2i is negative 4i squared, or plus 4, which leaves me negative 6 plus 6i divided by 8. If I reduce all of those, actually we're going to split it up. Negative 6 over 8 plus 6i over 8. And you can reduce those to negative 3 over 2 plus 3i over, I said over 2, over 4. And lastly, now I can go ahead and convert that to polar form. So that gives me negative 3/4 squared plus 3/4 squared. And I will end up with 9/16 plus 9/16, which is 18/16. Okay, don't worry, we're just about there. So if I take the square root of that, the square root of the numerator is 3 root 2. The square root of the denominator is 4. 3/4 root 2. That's your R value. Now your theta, think carefully. Both my x and y are exactly the same number, but they're opposites because of the quadrant they happen to fall into. So this has to be a 45-degree angle. What quadrant is it in? Well, it's negative positive, which means it's in the second quadrant. So this final answer for 5 is 3 root 2 over 4 cis. The angle value that has a 45 in the second quadrant is 135 degrees. All right, you're going to try example 6. Let's go ahead and quickly summarize everything we've learned here. So for multiplying these numbers, multiplying polar complex numbers, we have to multiply the r's and add the thetas. To divide polar complex numbers, we will divide, which often just means reduce the fraction, the r values, and subtract the thetas. Now we have to keep in mind that we want our theta value to fall between 0 and 360 degrees, which means sometimes you'll have to adjust that to find a coterminal angle. Go ahead and make sure you've got all the notes and that you've tried those two examples, and we'll take a look at this together.